Good morning, students. Welcome to the lecture 2, where we will be discussing about the stress and strain. So, without wasting any time, let's start with the topic. Now, in rock mechanics, we have two different property of rock that is said to be the fundamental property, the fundamental property that we need to know. Well, let me start with stress. uh, the definition of stress is a quantity that describes the internal forces within a body. For example, if a block is subjected to two force, it will have an amount of internal force that will act against this force. Similarly, from this side we'll have the forces in this direction internally. So this is the basic concept of stress is nothing but the force per unit area. So the stress is denoted by tau, which is equal to force per unit area. Now, as we all know, SI unit of force is Newton and area can be written as meter square, which is also written as Pascal. So this is the SI unit of stress. Am I clear? I hope I'm clear. So there are two kind of normal stresses. Well, before that, there are two kind of stresses. Stresses are of two kind. The very first kind is normal stress, and the second is shear stress. Okay, so let us go to normal stress. The normal stress is of two types, that is tensile stress and compressive stress. Keep noting down, please. So, the tensile stress, suppose a body is subjected to force in this direction, the body will elongate in this as well as this direction. The, the stress in this body will be known as tensile stress, and it is positive. Now let's come to compressive stress. A body subjected to stress in this manner, where the particle will compress, the length will be shortened, is known as compressive stress, and this is negative. Now we'll come to the fundamental concept used to discuss how a body responds to fundamental load. This will be discussed later. Let us come to strain. Now, what is strain? Please note down the definition of strain. Strain is a general quality that describes the deformation that occurs within a body. Well, the deformation in a body will be always this way. Suppose this is a fixed plane and we fix a body to it, and a force is applied in this direction, the body will somehow elongate So this was the original length of the body, and this is the elongated length of the body. So the strain would be equal to delta L by L, that is the change of length by the original length would be the strain of the body. Again, we have two types of strain: normal strain and shear strain. We have two type of strain too. Well, the strain is also compressive and tensile as in the case of stress, and the stress and strain behavior can be monitored through a graph, that is stress and strain graph, where we need to study we need to study the material and then plot a graph of it. uh, Let me plot the graph. Yeah, this graph is plotted through tensile test. We'll study about the test in further chapters. So you see, till this part we have an elastic deformation. I'm so sorry. Shit. Till this part we have an elastic deformation, and the rest is the plastic deformation. Okay, so the relation between stress and strain can be given by Hooke's law, which is sigma is equal to E by, where this E is known as, where let me write down the Hooke's law again. The Hooke's law, this is the stress, this is the strain, and this is the Young's modulus. Young's modulus. So if you look closely, we can write it as Young's modulus is equal to stress by strain, stress by strain, which is, sorry, which is again a very important relationship in rock mechanics. Now let us come to the shear stress and shear strain, which is a very important topic to understand. Nothing difficult. Shear stress and shear strain. Okay, so uh, just visualize a body. Just visualize it as a body. If the force is in this direction, the stress would be force by area. This is clear to be all, to us all. But if the stress is in this direction, but if the force is in this direction, the deformation will be taking place this way. It means when the force is perpendicular to the surface, there is normal stress. But when the force is parallel to the surface, the stress that occurs in a body is the shear stress. Okay, so again let me draw a body. We have a body, and this is the parallel force, this is the area. So again the stress force, I'm indicating it as area, the area. So the shear stress would be equal to force upon area, that is the same. Remember, this is fixed. at the bottom. Okay, now let us come to shear strain. When the force is applied, so the body will be deformed in this direction, somewhat like this. Okay, when this is fixed, the base is fixed, we had the force in this direction, we had the force in this direction. So this is the length, the original length L. This is the changed length delta x, and we see an angle theta forming here. So shear stress, shear strain is nothing but tan theta, and tan theta is nothing perpendicular by base, uh, sorry, tan theta is nothing but delta x by L in that diagram, that is the shear strain. I hope I'm clear with the stress and strain things. Now let's come to isotropic and anisotropic. This is very easy. Isotropic refers to the material or the rock which have identical properties in all the direction, and anisotropical anisotropical material or rock are the rock whose properties changes with direction. Well, that is all for today. Thank you very much.